Okay, so here's a quick intro to parametric equations. So a parametric equation is where the equation is defined in terms of a third variable. So let's get an example. Okay, so if we have x equal to 2t, and we have y equal to t squared, and then we have a domain which is defined in terms of t. So normally what I do is I draw two axes. My two axes are y, and my horizontal is x. Okay, now this is called the Cartesian plane. Okay, so that basically means, if anybody's read Descartes, that means that basically everything on the Cartesian plane is plotted because it has an x and a y. Now the problem here is I've got a third variable, which is t. So I can't plot this equation onto this Cartesian plane. So what I need to do is I need to think about it a little bit differently. So what I'm going to do is I'm going to basically put t in terms of x. So if x equals 2t, that means that t must be equal to x over 2. Now, y is equal to t squared. Now I've got t in terms of x. So if I substitute this into my expression for y, I get x over 2 squared, which gives me x squared over 4. So now I've got an expression for y in terms of x. So I can plot this onto my Cartesian plane using x and y. The only other thing I need, my domain was defined in terms of t. And remember, basically the domain is the input, that's my x values. So I need to basically define this in terms of x. So when t equals -3, remembering that x is equal to 2t, that means that x equals -6. When t is equal to +3, that means that x is equal to +6. So my domain is going to be x greater than -x, less than +6. Okay, only one more thing to think about, and that's when you think about our range. So again, remember our range is y, that's the output of a function. So y is equal to t squared. So if t is -3, that means that it's going to be equal to y is going to be equal to +9. If t is equal to +3, y is also equal to +9. But remember that this is actually quadratic. So here we've got x squared divided by 4. It's just a normal quadratic curve. Okay, it doesn't cross the x-axis. So that means that basically our minimum must be 0. So our range can be 0 because our graph touches 0. So y is between 0 and 9. And that's our range. Let's look at another example. Okay, it's going to be a bit more complicated. So now let's define x as log normal of t plus 3, and y is equal to 1 over t plus 5, and our domain is t greater than -2. Okay, so again, what we're going to do is we're going to try and turn this to a Cartesian form where y is written in terms of x, and then we'll be able to draw the graph. If you want to have a go at this, stop the video, give it a go, compare it to what I write in a second. Right, so we've got x in terms of t, so now we need to write t in terms of x. So what have we got? We've got x equals log normal of t plus 3, so if we raise them both e, so we've got e log normal t plus 3. Okay, and we know that basically these two are inverses of each other, so they just cancel each other out. So that means that we've got e to the x is equal to t plus 3. Okay, so now all I have to do is put t on its own, and t is equal to e to the power of x minus 3. Okay, so now I can take my t, my y is 1 over t plus 5. So I'm going to take my definition of t and put that here. That's e to the x minus 3. Okay, so now we need to think about our domain. Now, when t is equal to minus 2, okay, my x is equal to the log normal of minus 2 plus 3, which is the log normal of 1, which we all know, hopefully, is equal to 0. Okay, now, there's no limit to this. So as t gets bigger, that means that basically our e to the x will keep getting bigger. And that means that basically we will get a smaller answer. So if we get 1 over our minimum of minus 1, our range is going to be y equal e to the x minus 3 plus 5. Okay, so remember that our x is, the smallest is going to be 0. So that means that this is going to be 1 over e to the 0 minus 3 plus 5. And we all know that e to the 0 is 1. So 1 minus 3 is going to be minus 2 plus 5. So that is a third. And then every value as that e to the x gets bigger, our denominator gets bigger. So as x tends to infinity, y will go to 0. So our range is that y is less than 1/3, because that's going to be the biggest value when we have our minimum x value. So we've turned it into a Cartesian form. We've changed our domain in terms of x. We've got a range. We can look at the graph of that function. Remember, basically our domain starts at 0, so it goes from there, and our range is going down, 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 down. Never got to 0. It's going to form an asymptote because it's smaller and smaller. And so that's the idea of a Cartesian equation. They get much more complicated, but that's the basic idea.